Hello Math 1093, this is Dr. P with two angles, one side. In this video we're going to solve a problem in which we are given a triangle. We're given one side length of that triangle. This side is 9 centimeters long. Probably depends on what size monitor you have. This angle has measure 62 degrees. This angle has measure 41 degrees. And our job is going to be to find the remaining angle measure and the other side lengths. Alright, to do this we're going to use a tool that is called the law of sines. The law of sines states the following for any triangle ABC. So if ABC is a triangle, and we follow the usual conventions where A, B, and C are the side lengths, opposite vertices, A, B, and C. Alright, so given that convention we have the following. A over sine of the measure of angle A is equal to B over the sine of the measure of angle B, which is also equal to C over the sine of the measure of angle C. That's the law of sines. You'll notice that that gives us a couple of different equalities there. And at any given time we're usually using just a couple of these pieces. So we're relating these two, or perhaps we're relating this to this, or perhaps we're relating these two. Okay, we don't usually use all three of them at once. Alright. So in this problem, I want to find all the remaining measurements of this triangle. Now actually there's one of these that I can find without using anything as high-tech as the law of sines. I know that I have angle measures of 62 degrees and 41 degrees. So I can definitely find the other angle measure because in Euclidean geometry I always know that the sum of triangle angle measures, that is interior angle measures, is 180 degrees. Alright, so I know that this angle, if I call this, let's just call it theta for now, I know that 62 degrees plus 41 degrees plus theta has to be equal to 180 degrees. Those two angles, 62 and 41, come out to 103 degrees, so 103 degrees plus theta is 180 degrees. So theta is going to be, sorry, that's not a plus sign, that's an equal sign there. Theta should be equal to 77 degrees. So I'm going to go ahead and mark that there. Probably will come in handy later. Okay, so the key to using law of sines is to develop kind of a structure sense about this formula, or this equality here. Okay, notice that this equality involves three ratios, each of which is the ratio of the length of a side to the sine of the opposite angle. Okay, that's each of these. This is B, this is the sine of the angle opposite B. This is C, this is the sine of the angle opposite C. I'm going to do a little bit of labeling here just to support us in using that rule. So I'm going to call this side A, which means this opposite vertex has to be A. And I'm just going to name the other two vertices kind of haphazardly, call those B and C, which means this opposite side will be B, this opposite side will be lowercase c. Alright, and we're going to try and find lowercase b and lowercase c. We've already found the measure of angle A. We know that angle A, let me put this over here somewhere, so this will be like my answer box. Maybe I should do this more often, create like a well-defined answer box. Okay. Anyway, in the answer box, I'm going to put that the measure of angle A is 77 degrees. Remember, I use the capital letter A both to represent a vertex and the measure of the angle at that vertex. Okay. So we want to find the length of side B and the length of side C. I'll just put those for safekeeping. All right. So now I'm just going to think about what it is I have in this triangle. I have one side length and the measure of this opposite angle, that's 77 degrees. So I can actually find the value of this ratio here, which I think I'll go ahead and do. I know that A, get my pen out, A over sine of measure A is 9 centimeters over the sine of 77 degrees. And I'm going to ask Cortana, ching ching, what the value of that ratio is. That is 9.2367. So I'm going to write that down, 9.2367. Okay, and actually I'm going to go ahead and put centimeters there because that actually does represent something, believe it or not. This quantity here actually ends up, so this is just a fun fact, which it's not terribly important for us to know right now. Fun fact is that this is the diameter of the circle that circumscribes the triangle. And you can look up a proof of that on the internet. I'm not going to do that in this video here. Okay, so in other words, if I were to draw a circle going through all three of these vertices, that circle would have a diameter of 9.2367 centimeters. Anyway, no need to know that in order to use the law of sines. It's just a fun fact. Okay, so now let's see if we can use the law of sines to figure out the value of b. Because my thinking here is, I know what this is, I know what this is, I know what this is, so I should be able to find this fourth thing in this proportional equation here. Okay, so I'm going to go ahead and do that. And in fact, I'm going to do that more in symbols rather than use this quantity I just found. That might come in handy later, but actually, more typically, we will end up with less error due to intermediate rounding if we work with this equality symbolically. That is, work in symbols before substituting. All right, so this is the thing that I want. I want to find the length of side B. So to do that, I'm just going to multiply both sides of this equation by this thing, sine of B. So I get that B is equal to A times the sine of B over the sine of A, and A was 9 centimeters. Sine of B, I'll figure out later, but sine of B I know is going to be the sine of 62 degrees. And then over the sine of, what was that? Not 40. It was, A was 77 degrees. And now I'm going to use my calculator to figure out what that is. Let's ask Cortanus, 9 times sine 62 degrees over sine of 77 degrees. That gives me 8.15, let's just call it 8.16 centimeters. That's just due to rounding there. Okay, and it never hurts to just look at your picture and see if what you're doing makes any sense at all. Okay, it makes perfectly fine sense for this to be 9 centimeters, even though on your screen it probably isn't 9 centimeters. This does look like a 62-degree angle. This does look like a 41-degree angle. This does look like a 77-degree angle. When you do the online homework for this, sometimes they will give you a picture where the angle measures really just do not seem consistent with the picture. And at that point, if you get some length that looks totally out of skew with the picture, that may be because the picture doesn't even make sense for the given info. But here, I have a picture that is pretty consistent with the given info, so this had better look like an 8.16 centimeter length. And when I look at this, it seems reasonable. Like it looks like this side length is not quite 9 centimeters, but it's pretty close. It's about 8.16 centimeters. So that seems reasonable. I'm going to go ahead and put it in my answer box. 8.16 centimeters. Okay. What about the length of C? Well, I know that I have the sine of angle C. That's this thing, sine of 41 degrees. I know I have the sine of A. I know I have A. A is 9 centimeters. Sine of A is sine of 77 degrees. So I have this piece, and this piece, which means I can find this fourth piece here. By the way, when I pick which law, I'm going to use law of sines, law of cosines when doing a measurement problem. I always try to find a law that I can use where I have all of the pieces of information I need except for one of them, and I can solve for that last thing. So if I have two angle measures, like, well, let's say this one, and I have one opposite side, and I'm looking for the other opposite side, boom, that's a law of sines. So anyway, so I'm going to write the rule, A over sine of A equals C over sine of C. Again, I can just use two of those at a time. It's perfectly fine. They're all equal. And then C is going to be A times the sine of angle C, trying to make those uppercase letters look uppercase, over sine of A. And that's going to be 9 centimeters times the sine of 41 degrees over the sine of 77 degrees. Again, let's ask our calculator for help. 9 times sine 41 degrees over sine of 77 degrees. That comes out to we'll call it 6.06 centimeters. 6.06 centimeters. Okay, by the way, probably we should be using little squiggly equals for these because these are all approximations here. Okay, even in the answer box, we should probably use them. That's 77 degrees as far as we know is exact. We just got that by subtraction from 180. Anyway, so for C, I get a length of 6.06 centimeters. And again, looking at the picture, it seems pretty much on target. I mean, this is not as long as this 9 centimeter side. And it looks like it's about 2/3 the length, and 2/3 would be, well, it would be 6. So 6.06 centimeters. Okay, so what we've done there is we have now, switch colors here, we have now solved the triangle. In other words, we have found all of the remaining measurements of this triangle. And in fact, we found all of the remaining measurements this triangle could possibly have. In other words, we've done enough to demonstrate that not only are these possible measurements for the rest of the triangle, these are the only possible measurements, because the law of sines only gives us one possible value for B and one possible value for C. If we'd been looking for angle measures, like if we'd been looking for more angle measures, it's possible we get multiple values of those, and we'll try and talk about that at some point.